It's funny. Usually when we talk about making a medical diagnosis or something, there's this expectation of like total precision.
Right, yeah, like it's engineering or math. You want it to be clean.
Exactly. You break your arm, the x-ray shows that jagged white line, and the doctor just points and says, there it is, broken.
Yeah, it's very binary.
It is, and we like that. We like things to be visible and neatly categorized and immediately solvable.
I mean, that's just human nature. We want the easy answer.
But then you step into the world of living, breathing ecosystems, even the really tiny ones, and suddenly that x-ray machine is just, well, it's completely useless.
Oh, absolutely. You're looking at a diagnostic landscape that is honestly incredibly murky.
Yeah, it really is. And that murkiness is exactly what we're getting into for today's deep dive. We are looking at a journal entry from a gardener named Ang.
Published on July 11th, 2026.
Right. And the title of this entry is so telling. It's called Notes on Gardening, Part 952.
Part 952. I mean, that detail alone tells you pretty much everything you need to know about the observer here.
Seriously.
This isn't someone just casually tossing a packet of seeds into a pot of dirt on a Sunday afternoon and, hoping for the best.
No, definitely not.
This is a sustained, deeply systematic engagement with the natural world. Because reaching part 952 of anything requires a tremendous amount of patience.
Yeah, and a willingness to document failures just as meticulously as the successes, right?
Exactly.
So the focus of this specific entry is a highly specific and, honestly, a very frustrating failure. It's about the seed propagation of a plant called the Abutilon Pictum.
Which is more commonly known as the red-vein-indian-mallow.
Right. Now, if you were listening to this right now and thinking, I don't care about gardening at all, stick with us.
Yeah, please do. Because this is about so much more than a plant.
It really is. This journal entry is essentially this highly relatable look at how we apply the scientific method without even realizing we're doing it.
Right. It's an exercise in observing a system that just isn't working, realizing your baseline assumptions are completely wrong, and then figuring out how to intervene.
So let's get into the setting here, because the environment is crucial to everything that happens next. Ang is working within a very specific microclimate.
A backyard balcony microclimate.
To be exact.
Yeah, let's unpack that setting.
Yeah.
Because when you say backyard balcony microclimate, that paints a picture that is actually quite harsh.
Oh, it's brutal.
Right. Like, a lot of us have tried to keep a houseplant alive on an apartment balcony and just watched it wither away. A balcony isn't a sprawling meadow.
No, it's this artificial, suspended little world. It is essentially an alien planet for a plant.
It really is.
When you take something like the red-vein-indian-mallow, which, is a subtropical shrub native to South America, and you place it on a concrete balcony, you are stripping away its entire evolutionary context.
Because on a balcony, the basic physics of the environment are totally warped.
Exactly.
You got concrete walls and floors that just soak up heat all day long and then radiate it back out all night. So you're disrupting the plant's natural temperature cycles. And then you have those sliding glass doors acting as massive magnifying glasses, just blasting the plant with intensified UV rays.
Oh, man, yeah. And we can't forget the wind.
The wind is a huge factor. Ground-level vegetation benefits from the friction of the earth.
Yeah.
Trees and hills that break up the wind.
Right.
But on an elevated balcony, you often get these harsh, concentrated wind tunnels. And this strips away the microscopic boundary layer of humidity that a plant desperately tries to maintain around its leaves.
Wow, so the plant is just constantly dehydrating.
Constantly. It's fighting just to maintain its basic cellular functions.
So into this suspended concrete crucible, Ang places this Abutilon Pictum, and it's struggling. It is having a really hard time acclimating.
Very understandably.
And this is the inciting incident of the whole journal entry. Despite this intense struggle, the plant is still blooming.
Which is fascinating.
It is. It's regularly producing these beautiful bell-shaped flowers. They look a bit like paper lanterns with these distinct red veins. But Ang notes that it's producing numerous spent flowers.
Right. Flowers that bloom, wither, and then just drop off.
And this brings us to the first major hurdle. Ang looked at all these spent flowers and made a very logical but fundamentally flawed assumption.
It's an assumption almost anyone would make, honestly.
Right. The assumption was that the presence of a spent flower naturally meant the presence of seeds.
Ang thought, oh, I have all these spent flowers. I can just harvest them, open them up, and propagate the plant.
Because it makes sense intuitively. We see the end of a flower's life cycle and assume its reproductive job was finished.
Yeah, you plant a tomato, the yellow flower blooms, the flower dies, And behind it, a tomato grows with seeds inside.
Exactly. You assume the withering of the flower is the finish line, but Eng realizes a really hard botanical reality here.
A very harsh lesson. Unless those flowers are actually pollinated, you cannot extract any seeds from them.
A spent flower does not automatically equal a seed pod.
It's such a common misconception. We tend to view a flower blooming as an achievement in itself.
Right, like the plant did its job.
But biologically, a flower is just an advertisement. It's a mechanism to attract a pollinator. If the pollinator never shows up, the flower just eventually dies of old age, having accomplished literally nothing.
It's like, okay, think about it this way. Assuming a spent flower automatically yields seeds is like assuming that because your kitchen oven timer went off, your cake is perfectly baked.
Oh, that's a great way to put it.
Right. That assumption completely ignores whether you actually mixed the flour, sugar, and eggs together and put them in the oven in the first place.
That analogy captures the mechanical failure perfectly. The oven timer going off or the flower blooming and withering is just a chronological event.
It's just time passing.
Exactly. But baking the cake, the actual mixing of the ingredients,
Yeah.
that is a chemical and physical process. And in the plant's case, that process is pollination.
The timer went off, the flour died, but the bowl was empty.
The ingredients were never mixed. Eng discovered that the biological reality isn't about time passing. It's about a highly specific, choreographed physical interaction that was entirely missing on that balcony.
And this realization forces Eng to completely change tactics, because you can't solve a problem until you realize what the problem actually is.
Right. The focus has to shift entirely.
Away from how do I harvest these seeds to why didn't the mechanics of pollination happen in the first place?
We have to move from what is happening to why it is happening. We have an endlessly blooming plant, fighting for its life, pouring its limited energy into these flowers, and just failing completely.
So why is this plant not getting pollinated? The journal entry starts exploring the environmental and ecological limitations of this balcony.
And the most obvious limitation connects right back to what we were just saying about the balcony being an artificial suspended world.
The microclimate probably just lacks compatible pollinators. Eng specifically notes a lack of hummingbirds or native insects up there.
Right. In its native habitat, the red-vein-indian-mallow is part of a massive interconnected web. Its bell-shaped flowers are specifically designed to accommodate the long beaks of hummingbirds or specific insects that crawl deep inside to retrieve nectar.
Brushing against the pollen in the process?
Exactly. But a balcony is an ecological island. It is physically elevated, completely separated from the natural ground-level corridors that these pollinators travel.
It's like throwing a party at an exclusive VIP club, but there are no stairs or elevators to get to the front door.
Yeah, perfect.
The music is playing, the lights are on, but the guests physically cannot reach the venue. The flowers are sending out a signal, but they are broadcasting to an empty sky.
And that isolation triggers a cascade of other problems, which leads to Eng's next deduction.
Okay, what's the second suspect?
Well, the isolation and the harshness of the balcony mean the plant is still deeply stressed by acclimation. Eng theorizes that this stress could be causing the plant to drop its flowers prematurely.
Oh, right. Because acclimation isn't just a waiting period where the plant gets used to the view, it is an incredibly demanding, energy-intensive process. As we mentioned, it's fighting wind shear, fighting weird temperature fluctuations from the concrete. When a plant is under that kind of acute, sustained environmental stress, it goes into triage mode.
Exactly. The plant is constantly running this metabolic calculus. It senses the season, the daylight hours, and its internal programming says it is time to reproduce. Send out a flower.
So it expends precious energy to create that flower.
But as the flower opens, the plant is simultaneously dealing with dehydration from the wind or a lack of humidity. And developing a fruit and seeds is one of the most energy-draining things a plant can do.
So it panics.
Basically, yeah.
Yeah.
Before the flower even has a chance to fully mature or wait for a pollinator, the plant's survival mechanism kicks in. It aborts the mission. It drops the flower prematurely to conserve energy for its root system and its core leaves, just to stay alive.
It's saying, look, I can't afford to sustain the next generation right now. I am barely surviving myself.
Exactly. So it just jettisons the bloom.
Wow. But Eng also brings up a third possibility, right? And here's where it gets really interesting to me, because this shifts the blame away from the balcony environment and onto the plant itself.
Yes. The third limitation.
What if this particular cultivar of the Abutilon Pictum has reduced fertility or is just functionally sterile?
Which happens a lot.
Right. A lot of plants we buy at nurseries are bred for how their flowers look, not for their ability to reproduce, and sometimes that breeding makes them sterile.
Exactly.
But if a plant is functionally sterile, does it just continue to expend all this vital, precious energy blooming? Like, is it just churning out flowers, totally unaware that its efforts are futile?
Yes. And it highlights the somewhat tragic nature of evolutionary programming.
Tragic is the right word.
A plant does not possess a feedback loop that tells it its own genetics are broken. It is driven entirely by external chemical and environmental signals.
So it's just following a script.
A hardwired command. If the temperature and the daylight hours dictate that it is time to reproduce, the plant will follow it. It will pour its reserves into creating these complex, beautiful structures, completely blind to the fact that the biological loop is broken at a microscopic level.
Man, that is just a brutal loop of doomed effort. The plant's programming hasn't received the memo that it's a genetic dead end.
No, it hasn't.
So those are the dynamics at play. We have the VIP club with no stairs, no hummingbirds or insects can reach the balcony.
Right.
We have the triage situation. The plant is so stressed by the microclimate that it's jettisoning flowers early.
Yeah.
And we have the tragic loop, the possibility that the plant is just sterile and doesn't even know it.
So we have diagnosed the potential breakdowns in the system.
Yeah.
But observation alone doesn't solve the problem, right?
No, you have to do something.
The natural progression for any gardener or any scientist is to ask, how do we test these theories? How do we intervene?
And Ang decides to step in with an action plan, moving from observation to action. It's a two-pronged approach to intervene before reevaluating the whole situation.
Which is very smart.
Step 1. Attempt hand pollination using a small, soft paintbrush. Step 2. Relocate the plant to a spot on the balcony with higher sunlight exposure.
It is a very systematic approach that addresses multiple variables at once.
Let's break down this paintbrush idea first, because visually this is striking. You have a person standing on a concrete balcony holding a small art brush, effectively becoming a substitute for a hummingbird.
It's quite an image.
But just so I have the mental picture, right, of what Ang is actually doing here, Ang is taking the brush, going inside the flower, and taking pollen from the stamen and moving it to the pistil, right?
That's right.
The stamen is the part producing the pollen, and the pistil is the target that leads to the ovary.
That is exactly right. The stamen is the male reproductive organ, which holds the powdery pollen. The pistil is the female reproductive organ, usually located right in the center of the flower, which receives the pollen. In a natural setting, a hummingbird shoves its face into the bell-shaped flower to get nectar. As it does, its feathers brush against the stamen, picking up pollen.
Right, they get dusted with it.
Exactly. And when it pulls out, or when it goes to the next flower, those pollen-coated feathers brush against the sticky surface of the pistil, depositing the pollen.
So by using the soft paintbrush, Ang is manually transferring that pollen.
You are mimicking the soft friction of the bird's feathers or an insect's legs.
If the first issue is simply that the biological couriers the hummingbirds are missing from this elevated ecological island, the human just becomes the courier.
Yes.
You are bypassing the isolation of the balcony entirely. You are doing the mixing of the cake ingredients yourself.
You are directly injecting yourself into the mechanical failure of the system.
I love that.
But Ang doesn't stop there because manual pollination only works if the plant is healthy enough to actually develop the seeds afterward.
Right, which brings us to the second part of the intervention. Relocating the plant to a spot with higher sunlight exposure.
And this addresses the second issue, the environmental stress and the triage mode.
Giving it more fuel, basically.
Correct. Sunlight is the primary driver of photosynthesis, which is the engine of the plant's energy production.
Makes sense.
If the plant is prematurely dropping its flowers because it is in a state of stress and lacks the energy reserves to sustain fruit development, the logical countermeasure is to give it more fuel.
So by moving it to a higher sunlight exposure area on the balcony, Ang is increasing the plant's overall energy budget.
Exactly. You are trying to give the plant the physiological fortitude it needs to hold on to those flowers long enough for your paintbrush intervention to actually take hold and create a seed pod.
It's so smart. You control for the mechanical failure and you control for the energy deficit simultaneously.
And then comes the most important phrase in Ang's journal entry, before reevaluating the situation.
Oh, right, because science doesn't stop after one test.
Exactly. You don't just intervene once and assume it worked. You observe the results of the new variables you introduced.
Did the flowers stay on longer? Did a seed pod begin to swell?
It shifts the gardener from being a passive consumer of a plant's beauty to an active, vital participant in its life cycle.
It really is a journey of realization. We started with this single entry, part 952. We started with a frustrated gardener looking at a struggling red-vein-indian-mallow, assuming a withered petal meant a guaranteed seed.
A very human assumption.
And then we followed the realization that the oven timer doesn't bake the cake, that pollination is a physical requirement. We explored the isolation of the balcony, the stress of triage, and the tragic possibility of a sterile plant.
And finally, we arrived at this incredible image of a person wielding a soft paintbrush, stepping in to become the ecosystem.
And for you listening, I think there's a takeaway here that extends far beyond a balcony garden.
Oh, absolutely.
Because whether you are trying to figure out why a project at work is failing, why a team dynamic has stalled, or why a literal plant on your windowsill is dying, the lesson is the same.
It's about looking deeper.
Sometimes sitting back and expecting the system to just work on its own isn't enough. Sometimes you have to realize the underlying mechanics are broken.
You have to step in.
You have to change the environment, give it more sunlight, and you have to become the hummingbird. You have to pick up the paintbrush and manually mix the ingredients yourself to get things moving.
That is the real power of observation and intervention. However, and this is important, it does leave us with one final lingering question.
Okay, what's that?
A question that sits just beneath the surface of Ang's experiment. We've discussed how the paintbrush solves the missing pollinator problem and how the sunlight addresses the energy deficit. But what if the third hypothesis is the correct one?
Wait, you mean the sterile cultivar hypothesis? Like, what if the plant itself just cannot reproduce no matter what?
Exactly. If this particular Abutilon Pictum is indeed functionally sterile, then its relentless blooming is already a futile drain on its limited energy. If that is true, then moving it into higher sunlight to fuel even more blooming and manually stimulating it with a paintbrush might simply trick the plant.
Oh, no.
It might accelerate its energy depletion on sterile blooms that will never produce seeds.
That's wow.
We have to wonder, in the very act of trying to save the plant and propagate its future, could human intervention ultimately be the thing that exhausts its last reserves and dooms it?
Man.
It's a sobering reminder that when we step in to fix a system, we must always be prepared for the unintended consequences of our own help.